Okay, it's Monday, May the 4th, and we're here to talk about mass percent composition, and we're for our Espanola Valley High School chemistry students. Okay, before we begin, let's talk a little bit about why we do mass percent composition and say what percent composition is. First off, it's given a particular compound, what percent of it by mass is due to each element that makes up that compound. For example, water, H2O. So if I have water, what percent of it is hydrogen? What percent of it is oxygen? That's all we're going to do here. It's a very, very trivial calculation. What information do we need to know how to do before we do this calculation? The only bit of information we need to know how to do is how to calculate a molar mass, which we learned 2 weeks ago, how to calculate a molar mass during week 2. So all of us should know how to do that. That's another rather trivial calculation, okay? Although it is easy enough to screw it up. All right, so why are we interested in this mass percent composition? In and of itself, it's purely just an exercise, okay? It's in and of itself, it really has no utility or application. However, the second thing we're going to do this week, which is the mass percent composition, not of a compound, but, mass percent composition of a sample of a compound. Now, that's a little different from mass percent composition of a compound. For example, we just talked about water, right? So if I have water, what percentage of any sample of water is due to hydrogen? What percentage of any sample of water is due to oxygen? However, if I have a big ice cube and I want to know how many grams of oxygen are in this chunk of ice, okay, that's a slightly different problem. And that's what we're going to do for the second problem this week. And there's a third type that involves percent composition that I'm not going to have you do, which is, and this is something that the police might do in a forensic laboratory, or if an analytical chemist has to identify some unknown compound. This is a tactic they might employ. They get a sample of a compound and they figure out what we just talked about for the second assignment this week, what percentage of that compound is due to each element, or of that sample is due to each element. And from that, we can figure out what the chemical formula is. Okay, but we're not going to have you do that in the interest of time. We're kind of short of time here. We only have this week and next week left to do. Okay, so without further ado, let's take a look at how to calculate mass percent composition of a given compound, chemical compound. So let's take a look. And I'm just going to put percent here because I don't have a lot of room to work. A percent sign, I should say. And let's see. And we'll put a 2 there. And we'll give you a moment to copy this down. So the very first thing we have to do is calculate the molar mass of calcium nitrate. Okay, the compound of interest in this problem. So I'm going to go ahead and do that on the small board here. So I write the formula unit, and 1 calcium And 1 nitrogen times 2 is 2 nitrogens. 2 oxygens times 2 is 4 oxygens. Right, multiplied by their masses off the periodic table. And we get our calculator and add them up. And I'm going to do it a second time. Make sure I get the same answer. If you watched the dilution video from last week, you'll see where I only calculated it once and I made a mistake. That's why I'm always telling you folks. Yep. Okay. So you do every calculation twice. All right, so we have our answer. 132.088, and our unit, as always, for molar mass is grams. Okay, grams. Okay, so I'm going to put that number into my memory because I know I'm going to need it here. All right, I know I'm going to need it. All right, so you should be able to understand what's going on here. Of the 132 grams, I want to know what percent of it is calcium. What percent of the 132 grams is nitrogen? What percent is oxygen? That's going to be very easy. For calcium, it's just going to be 40 divided by 132 times 100%. And that will give me my percentage. Okay, so I'm going to remember this number. Actually, I have it in my memory. And so I'm going to put calcium is, the mass percent is 40.078 divided by 132.088. And if we want, we can put the units in here. Grams, they're going to cancel, times 100%. And let's see, for nitrogen, that's going to be 28.014 grams divided by 132.088 grams times 100%. And for oxygen, 63.996 grams divided by 132.088 grams, the molar mass, times 100%. Okay, and we'll just write our answers out here at the end. Okay, and again, you see, we need the molar mass 3 times. That's why I put it into the memory on the calculator. So for calcium, 40.078 divided by recall 1 equals times 100 equals. Okay, and let's see, I can go up to 5 digits here. So 30.342%. Okay, because I have 5 digits here and 6 here. So my answer is limited by the fewest in the digits in the calculation. So for nitrogen, 28.014 divided by recall 1 equals times 100 equals. All right, and I get 21.209%. All right, and for oxygen, 63.996 divided by recall 1 equals times 100 equals 48.450. Percent. Don't forget to write percent there. Don't forget to write percent. Now, again, I'm going to do each of those over again, right? Just to make sure I didn't screw up like I did last week. Okay, so the calcium is okay. Okay, for the nitrogen and for the oxygen. Okay. Now, if I add all these percentages up here, this is another check, all right? I should get 100%. Now, we might be off by 0.001, all right, in the last decimal place due to rounding, all right? We might be off. So if I add those all up, I might get like 99.999 or 100.001, okay? But that's okay. That's due to rounding. So I'm going to add those up and see what we get. So 30.342 plus 21.209 plus 48.450 equals, and I get 100.001%. That's always a good check. Add up all your percentages. They should equal 100% within rounding error, okay, which is what we have here. So I think you guys can all agree it's a very trivial calculation. Very, very trivial, okay? So this is all this assignment is. All right, so I'll do another 2 or 3, however many you want me to do. All right, again, if some of you want to check out early, I don't have a problem with that, okay? Any questions or comments here? Any questions or comments? Well, I have one comment, which is, again, if you're smart, I told you this back when we were doing isotope percent composition, and to prove that when we were trying to reproduce the masses on the periodic table and to show that they were averaged over all of the naturally occurring isotopes. Okay, don't ever use the percent key on your calculator. Think of the percent here as just a unit, like grams or seconds or meters, right? It's just a unit. Don't use the percent key on your calculator. Multiply times 100, all right? Multiply times 100. Okay, that's my only comment here. All right, so if there's no questions or comments, I'm going to erase and we'll do another one here. Okay. So again, where can we make a mistake in this sort of problem? Well, one is calculating the molar mass. This is why anytime you calculate a molar mass, you got to make sure you do it twice, because it's always going to be used for something else in the problem. So you have to make sure that you get that right. Okay? All right. So let's look at another problem here. Let's see. Okay, so manganese 7 perchlorate. I don't know if this is a real compound, but we can at least pretend that it is for the sake of this problem. Okay? So I know I'm going to need the molar mass. I'm going to get out my little board here. And of course, you need a periodic table for this also. So I'm going to write down, remember, this is not chlorine and iodine. A lot of students, for some reason, want to turn that into iodine. Okay, so now we're going to write out the elements: manganese, chlorine, and oxygen. And I see 1 manganese, Now, there's one chlorine there, cover up. There's one chlorine times 7 is 7 chlorines. There's 4 oxygens times 7 is 28 oxygens. And now I'm going to multiply by the atomic masses off of the periodic table. Chlorine is 35.45. Oxygen is 15.999. And manganese is 54.9380. All right, put our equal signs. Again, don't get lazy. Put these equal signs and write your answers here. I've seen too many students add up the numbers here for the molar mass without doing the multiplication. It's just being lazy. All right, 7 times 35.45 equals 248.15 and 15.999 times 28 equals 447.972. Okay, so let's add these folks up. 54. I'll put that into my memory and do it all over again. Got to get the molar mass right. All right, I got the same answer. Remember that little trick I showed you using your memory? That the first calculation, you put it into memory. Do the second calculation and subtract the memory value. You should get 0 if both answers are the same. Okay, so we have 751.06 grams as the molar mass of manganese 7 perchlorate. Okay, everybody have this. Thumbs up whenever you have it, so I know I can take down the small board. Go back to the big one. Okay, 1 or 2 of us still working. Maybe off having breakfast. Okay, now I'm going to move on. All right, so 751.06. I know I'm going to need that number. All right, so it's in my memory on the calculator. So manganese, chlorine, and oxygen. All right, now, again, for manganese, it's going to be 54 divided by 751. So 54.9380 grams divided by 751.06 grams times 100%. All right, and chlorine was 248.15 grams. Remember, these grams cancel. I didn't point that out in the last problem, I don't think, or at least didn't emphasize it. So I'll be sure to do that this time. And finally, for the oxygen, 447.972 grams divided by 751.06 grams times 100%. And before I pick up the calculator, I'm just going to double check and make sure all these numbers here are correct. Okay, so the manganese is okay, the chlorine is okay, and the oxygen is okay. All right, so now we can grab the calculator. All right, so I have the molar mass, 751.06 in my calculator here. So for the manganese, 54.9380 divided by 751.06 equals times 100 equals. And I get 7. Now, how many digits should I have? Well, let's see. I have 5 here and 6 there, so my answer should have 5. And I get 7.314.7%. Again, remember here that as far as units, the grams here cancel in each case. The only unit that's going to be left is percent. So that's how I get percent over there. All right, let's do the chlorine. All right, so 248.15 divided by recall 1 equals, all right, and I get and multiply times 100 there. 33.0 after rounding, and I'm going to have 5 digits. 0.040%. And I'm going to put that into my second memory. And for the oxygen, 447.972 divided by recall 1 equals times 100 equals. And I get 59. Again, I'm going to have 5 digits. 59.645%. Okay. Now, I'm going to do the calculations each one more time. Put the oxygen one into the memory. Okay, so for the manganese, just double checking here. 54.9380 divided by recall 1 equals times 100, 7.3147. Okay, that is correct. Okay, and I'm going to put that into the first memory. And for the chlorine, right, 37 point, oh, I got a different number for the chlorine there, 248.15 divided by 751.06 equals, okay, times 100. All right, so there I got the same answer. So again, that's why we do every calculation twice. Okay, now we can add these up. Now we might be off a little bit because these have 3 decimal digits, this one has 4. Okay, so we might be off a little bit. So recall 1 plus recall 2 plus recall 3 equals, right? And I get 90, actually, with rounding, it does come to 100.000% upon rounding. Okay, it's actually more like 99.9997. If we're rounding to 3 decimal places, it becomes 100.000%. Okay, any questions here? Any questions? Okay, again, it's a very trivial calculation. Very, very trivial. But this is going to be the first step in the second assignment we're going to do later in the week. And I'll send out an email for what day we're going to do that. Any questions or comments here? Any questions or comments? It's identical to the first problem that we did. Okay, no questions or comments? So let's just see a thumbs up. How many of us think we could do the assignment right now? Okay. Oh, excuse me there, my phone is ringing. Okay. Get another robocall from the school, so your phone will probably be ringing also. Okay. I'm going to do one more here, and then I think we probably should be okay here. All right, I'll do one more. Okay, again, any question or comment? Any question or comment? Okay, I'll do one more. Yeah, this is pretty easy calculation. I took it easy on you folks for this online stuff. I know it's a challenge for all of us. I know it certainly has been for me. Okay, so let's look at yet another problem. Let's do a molecular compound this time. So sucrose is the sugar, I believe, in a packet of sugar that you get in a restaurant. All the chemicals produced in industry every year, sucrose is one of the compounds that has the highest production rate every year. Right? How many millions of tons of sugar of sucrose are produced every year, as you can imagine. Okay, now we know we're going to need the molar mass, so I'm going to get out the little board here. All right, so let's go ahead and write down the molecular formula here. And remember, molecular compounds have molecular formulas. Ionic compounds have formula units, but they are both chemical formulas. So carbon, hydrogen, and oxygen. So 12, 22, and 11. This one I don't need to grab the periodic table for. All right, let's get the calculator. Clear all the memories. $144.132. Put that in the first memory. And 22 times. And that's in the second memory. And 11. And that's in the third memory. Add them up. It doesn't look right. I know it's 342, but the decimal part doesn't look right. Let's try it again. Yeah, that's it. So we'll put that into the first memory and clear the other two. All right, so there's our molar mass. Okay. So the carbon mass percent composition is just the 144 divided by the molar mass times 100%. And likewise for the hydrogen and the oxygen. All right, but we'll give you a moment to copy this down. When you have it, please give a thumbs up just so we know you're finished. I think somebody has just logged in and gone off to do other things, thinking that I guess they think I was born last night. All right. So let's do carbon, hydrogen, and oxygen. Okay, now for times 100%, times 100%, and one more time. Okay, again, you cancel the grams in each case. All right, I can cancel the grams. So let's grab the calculator and get to work here. So for the carbon, 144.132 divided by recall 1 equals times 100 equals. Now let's see, in each of these I should have 6 digits. 6 here, 6 there. All right, so let's go ahead and do this. So 42.1073. Okay, for the hydrogen. Oh. One, I should only have 5 for the hydrogen. I got 5 digits here and 6 here. 1.8927. Okay, put that into the second memory. And last but not least, the oxygens. 51.414, and I should have 6 digits and a 1%. Okay, so let's check them all over again. All right, so the carbon is okay. The hydrogen. Yep, made a mistake. This one, you always got to do it twice. Yeah, I'm getting a different answer. 76 divided by recall 1 equals times 100. Well, it looks like the hydrogen is wrong. That's why we got to check it. I'm getting 6.4786%. Do that one more time just to make sure. Yep, okay. And finally, the oxygen the second time. Okay, now let's add them up. And that comes to 100.000%. Actually, should be another 0 there. Okay. All right. So, again, you see why we got to do every calculation twice to check. You do all this work, spend a few more seconds, check it, make sure that it's right. Okay, any other questions here? Any other questions? Now, again, as I pointed out at the beginning, this is a calculation in and of itself as an endpoint is not really of much use. Okay, but it's a starting point for two other types of calculations, one of which we will do later in the week and one of which we will not. Okay, so I don't think I'm going to do any more here. I think we're all good to go here, and you should be able to do the assignment no problem. Okay, I thank you for checking in, and hopefully we'll see you again later in the week. I'll send out probably tomorrow, when I get a feel for how many people are checking in with us, as to when I will do the Zoom sessions for the other topic. All right, so I'm going to end the recording here.